running across the top. The 5' end isn't modified. It's the exact way it came out of RNA polymerase, meaning it has a triphosphate end. And in this particular case, there's 3 open reading frames. Each one has what's called a ribosome binding site in front of it, and each one starts with an initiation codon of AUG, encoding for N-formal methionine, and using a tRNA FMET to put that in. So how does a ribosome in the bacterial world know where to get started? If it just went looking for an AUG, it would have the problem that it didn't know if it found the first AUG or some internal AUG. And particularly because there's multiple open reading frames that can be encoded on one transcript, it needs to find this AUG and use it as a start codon, but not find this AUG and use it as an internal or as a different start and skip this one. So how does it do it? Remember that the ribosome is actually a ribozyme, which means the catalysis is actually carried out by the RNA. But by the fact that it is a ribozyme, it has necessarily RNA in it. If the if the ribosome has RNA in it, it can use Watson-Crick base pairing between RNA and RNA to find specific spots. So it turns out that if you look at the 30S ribosomal subunit, remember how many RNAs are in it? 1, 2, 87, 64, 1. And the only RNA inside of it, I'll fold it up kind of crazy, is the 16S RNA. Turns out if you follow it all the way along, there's one bit that sticks out. And that one bit has a particular sequence to it. You can see it here. It's UCCUCCA. UCCUCCA. And that is running in a direction 3' to 5', which is the way you never write things, but it makes it convenient for me to pull an RNA through writing 5' to 3' that happens to have a sequence that will directly pair with that. This sequence was discovered by 2 scientists, Shine and Delgarno. Thus it's known as the Shine-Delgarno sequence. And when the mRNA pairs to the 16S RNA in the 30S small ribosomal subunit, when this pairing occurs, usually at a distance of no more than 10 nucleotides, you will find an AUG. When you find an AUG, everybody's happy. If you don't find an AUG, things aren't particularly happy. If this pairing isn't particularly perfect, things aren't happy. There's every variation one could dream of out there in science, but basically, the small subunit, remember, interacts with the mRNA. The mRNA is scanned such that the mRNA has to make direct contact with the anti-Shine-Delgarno sequence. When that takes place, this thing is relatively close to the P site, then here's the A site, and everything's kind of lined up, and you can slap the tRNA in there to get things going. You can see that my right hand now works again, sort of, kind of. So I will be continuing to write on the board for you. Those of you who are sitting all the way in the back, I sure hope you have good eyes, because that's about as big as I could draw up there on any details. Does that work? So any questions about bacteria?